The last part of this chapter is about circular linked list. We studied the single linked list, the double linked list, and now the circular linked list. Singular, doubler, and circular. Circular it forms a circle. It goes like in a loop. This type is similar to the singly linked list, except that the last element points to the first node of the list, not to an L. The linked portion of the last node contains the address of the first node. So the last portion points to the first one. Circular linked list, this is a struct called node and contains the value, the next, because it's a singular, and two methods here, and all these are private in the public sector of the circular linked list class. In the private sector, we have a node called tail and a list size, the size of the circular list. And the public, we have the constructor, we have a virtual, several virtual methods, one of them called size, the other one is called isEmpty, it returns 1 if it's empty. The peak shows the peak, add head, remove head. All right. And this is the node method. This is the node method, override, depends on the variables. And here's the constructor that initializes the list size, make it 0. And here is the circular linked size, returns the size. And here's the circle is empty, it returns 1 if the size equals 0. And peak, if it's empty, then give this message, otherwise returns the value. Right? Analysis. In the circular linked list, we just need the pointer to the tail node, as head node will be easily reached from the tail. So we just need the tail, all right? Size is empty, peak functions remains the same. Insert element in the front. To insert element at the beginning of the chain, circular linked list, we use this piece of code and we call it add head. Right? And here in the main menu, we call the class, we call the method add head several times, and we call the print method to print its details. And here's the analysis. To insert element at the end, here's the code, and it's called add tail method, which is part of the circular linked list class. And this is just checking if it's empty or not. And if it's not empty, then this is the way we add tail. We create a temporary pointer of the type not struct or structure, and the next of the tail equals the next of the temp equals the next of the tail. Then the next of the tail equals the temp that we would like to add. The tail equals the temp, and we increase the size by 1. All right. So we just put the next of the tail equals to the next. The next of the temp equals to the next of the tail, so it points to the first. All right. Then we need we just add tail. Adding a code at the end is same as adding at the beginning, just need to modify the tail pointer in place of the head pointer. Similar to the previous, but we changed the tail instead of the head. How to remove an element in the front, here, that's how we do it. right? Tail next equals next next. So we skip one, then delete. Me this one. No, that's tail next. And this way we remove the head, because the tail next that we just deleted is the head, right? And next the second element that became a head, and we decrease the size by 1. And here's the analysis. The next one is search an element in the list. Is it present? If it's there, we give the data and it returns 1 if it's present. So it checks the value. It goes through the linked list one by one, checks if the value matches, then returns true. And go next and keep going. I iterate through the list and find if a particular variable is there or not. Print the content of a list. We just print using cout. We iterate through it using the while statement. And each time we increase the pointer by 1 by going to the next. All right, delete list. We just delete everything. Just start from the beginning till the end, and each time we delete the current, right? We go to the next, we delete the current, then make the current equals to the next, and keep going. And this way we delete everything. We delete the tail equals null pointer, and list equals to 0, and this way we vanish the whole linked list. Delete a node. Given its value, we search by the value. Once the value matches the value of the node, we delete the node. We do this by this written code here. When the value equals a key, single node case, head case, just like that. Copy list reversed. To copy the entire list reverse, we use this while loop, and we add heads. To copy it the same, we add tails. If we keep adding heads, then it will be reversed. All right. Copy the list, we use add tail. Doubly circular list. For any linked list, there are only 3 cases: 0 element, 1 element, general case, and general case. To doubly linked case, we have few. So now we have another type. It's called doubly circular. Doubly circular. So it's a circular, but it's doubly. It's not like the previous one that's only circular. That looks like a singular. All right. To doubly linked list, we have few more things. We have null values. We have only elements. Always an if before a while, which will check from this head. General case, check with initial head kept. Avoid using recursion solutions. It makes life harder. So this is doubly circular. Each one has 2 pointers like the doubly, but it forms a cycle, so it's circular. And the double circular is not like the singular circular, just like the last one points to the first, but the first also points to the last, just like twice. And here's the class of the double circular list, and here's the node structure. And all these are methods. The public methods are the size is empty, pick head, add head, remove head, just like that. Search value is present. Traverse through the list and see if the given value, this one, the given one, matches the value or not, and we move to the next. We use the do while loop as initial state is our termination state too. So we did not use while, we used do while. To delete a list, we use the following code, this code. Delete the current, go to the, make it the next, and keep going. We use a while loop. Yeah. Free list. Print list is straightforward. We just do the do while and we just keep print out. Traverse the list and print its content. Do while is used as we want to terminate when temp is head and want to process head node once, at least once. Insert at the beginning or at the head. We use add head method. Insert at tail, we use add tail method as shown. Delete head, we use the remove head method. And it's written here. Delete tail node, we use the remove tail method. And here's the code that does that for us. And this is the end of the chapter. We have exercises, more exercises, the end of the exercises, and we have chapter 8 about the stack, and this will be in the next video.